The water in the swimming pool is heated to a comfortable 80 degrees, rippling gently against blue tiles deep beneath the freezing surface of the Arctic Ocean. It is 1982, and a few feet away, through a wall of steel and titanium, 20 ballistic missiles wait in silence for the order to end civilization. This is not a luxury resort, but the most dangerous machine ever built, designed to keep its crew sane just long enough to destroy the world. To understand the Soviet Union's Project 941, known to the West as the Typhoon, you must first look away from the torpedo tubes and the missile silos. You must look instead at the spaces that seem to belong to a different world entirely. Deep inside the steel belly of this Leviathan, there is a small gymnasium lined with heavy equipment. There is a solarium with sun lamps designed to mimic the ultraviolet radiation of a summer day on the Crimean coast. There is a sauna paneled in oak, smelling of heated wood and steam, a sensory memory of the forests far to the south. And, most famously, there is that swimming pool. It is small, barely 6 feet deep and hardly long enough for laps, but the mere fact of its existence is a staggering statement of engineering arrogance. For a sailor serving on a standard military submarine, life is usually a study in claustrophobia. In American Los Angeles-class attack boats or British Trafalgars, the crew sleeps in racks stacked 3 high, often sharing bunks in shifts. The air is recycled, the hallways are narrow enough that shoulders brush against piping, and personal space is a theoretical concept. But inside Project 941, the corridors are wide, lined with wood-patterned laminate. There is a living corner where songbirds chirp in cages and fish swim in aquariums. There are lounge chairs. It is tempting to look at these images, the grainy photographs of Soviet sailors relaxing in a sauna hundreds of feet underwater, and see them as a curiosity. It is easy to view them as a symptom of a superpower that had lost its sense of priority, focusing on luxury while its economy stagnated. But that interpretation misses the dark reality of what this vessel actually was. Naval historians and Cold War analysts have long noted that these amenities were not gifts. They were not built for the pleasure of the crew. They were engineering solutions to a terrifying physiological problem. This submarine was designed to disappear. It was built to leave its port in the Kola Peninsula, dive beneath the polar ice cap, and remain there, utterly silent and disconnected from the human world, for 3, 4, or even 6 months at a time. When human beings are trapped in a steel tube for half a year, denied sunlight and fresh air, the mind begins to fracture. Depression sets in. Alertness fades. In a machine where a single flipped switch or a misunderstood command could trigger a thermonuclear exchange, a depressed or distracted crewman is a catastrophic liability. The sauna, the pool, and the birds were not luxuries. They were maintenance systems for the biological components of the weapons system, the human beings. The existence of the pool underscores the paradox at the heart of this story. This was the most humane environment ever constructed inside a warship, yet it was wrapped around a payload capable of extinguishing life across an entire continent. The sailors floated in warm water, listening to the hum of the reactor coolant pumps, knowing that their primary mission was to wait for the order to unleash an apocalypse that would likely mean they had no home to return to. This jarring contrast between domestic comfort and absolute destruction defined the identity of the ship from the moment the world learned of its existence. In the West, it became a creature of myth almost immediately. Intelligence reports filtering back to Washington and London in the late 1970s spoke of something massive taking shape in the covered shipyards of Severodvinsk. Satellite imagery eventually confirmed a hull form that defied conventional naval architecture. It was too wide. It was too long. It cast a shadow on the pier that seemed impossible for a submersible vessel. The name Typhoon was not chosen by the Soviet Navy. It was a label assigned by NATO, derived, ironically, from a speech by Soviet leader Leonid Brezhnev. In an address to the Party Congress, Brezhnev warned that if the Americans proceeded with their new Trident submarine program, the Soviet Union would respond with a typhoon of its own. He meant it metaphorically, a force of nature, a disaster, an uncontrollable storm. The West latched onto the word. It fit their fears perfectly. To the NATO admirals staring at the blurry reconnaissance photos, this new ship represented a violent upheaval of the strategic balance. But Typhoon is destructive. It is loud. It ruins everything in its path. But inside the Soviet Union, the ship was never called Typhoon. Its official industrial designation was Project 941. Its crew and its designers called it Akula. In Russian, Akula means shark. The difference in naming reveals a profound difference in perception. A typhoon is a mindless disaster. A shark is a predator. A shark is a living thing that moves with purpose. It is an ancient creature, perfectly evolved for its environment, capable of stillness and patience. The Soviet Navy did not see this ship as a disaster. They saw it as the ultimate hunter, a guarantee of national survival patrolling the dark waters. While the West feared the destruction it could cause, the Soviets valued the protection it promised. The Shark was not just a new submarine, it was a new kind of object entirely. To understand why it shocked the world, one must grapple with its sheer physical scale. Numbers often fail to convey the reality of maritime engineering. But in the case of the Akula, the numbers are the only way to begin grasping the magnitude of the project. When fully submerged, the Akula displaced 48,000 tons of water. To put that into perspective, that is roughly the same displacement as a World War II-era battleship like the USS Iowa or the German Bismarck. But a battleship is a mountain of steel that sits on top of the water. It battles the wind and the waves. The Akula was a battleship that had to sink. Imagine the physics involved. An object weighing 48,000 tons had to be neutrally buoyant. It had to hover in the water column, neither sinking to the bottom nor bobbing to the surface. It had to be controlled with enough precision that a helmsman could keep it at a specific depth within a margin of a few feet. It had to move through a medium 800 times denser than air, and it had to do so quietly. This was the largest submarine ever built by human hands, and it remains so to this day. It was nearly 600 feet long, 2 football fields of steel end to end. But length is deceptive. Many submarines are long. The true shock of the Akula was its width and its height. From the keel to the top of the sail, it stood as tall as a 9-story apartment building. Its beam, the width of the hull, was nearly 75 feet. If you were to place an American Los Angeles-class attack submarine next to an Akula in a dry dock, the American boat would look like a child's toy. The American sub could theoretically fit inside the internal volume of the Soviet giant with room to spare. This immense size created a visual impression that was almost unsettling. When the Akula surfaced, it didn't just slice through the water, it erupted from it. The water would cascade off a deck that seemed as wide as an aircraft carrier's flight deck. Sailors standing on the casing looked like ants walking across the back of a whale. This size was not an accident, nor was it a result of Soviet megalomania, as some Western commentators suggested at the time. There is a persistent myth in Cold War history that the Soviet Union built things big simply because they lacked the sophistication to build them small. While it is true that Soviet miniaturization technology lagged behind the West, the size of the Akula was a deliberate choice driven by cold, hard requirements. The designers at the Rubin Design Bureau, led by the legendary engineer Sergei Kovalev, were not trying to set a world record. They were trying to solve a specific physics problem. As we will see, they were forced into this size by the dimensions of the weapon the ship was meant to carry. But the result was a vessel that redefined what a submarine could be. The sheer volume of the ship meant that it interacted with the ocean differently than any other vessel. Its inertia was tremendous. Once the Aquila began to move, it carried a kinetic energy that was difficult to arrest. Yet, records indicate that it was surprisingly agile for its size. The control surfaces, the rudder and the diving planes, were massive, seizing the water with hydraulic force to bend the ship's trajectory. This scale also meant that the Aquila was incredibly distinct in its sensor signature. A steel object of that magnitude disturbs the Earth's magnetic field as it moves. It blocks sound in a specific way. It creates a wake that can linger for miles. For the submarine hunters of NATO, the Typhoon was the great white whale, the ultimate prize. Tracking one required a different mindset. You weren't looking for a needle in a haystack. You were looking for a building moving underwater. But for the men inside, the scale meant something else. It meant safety. It meant room to breathe. It meant that the swimming pool and the sauna were not just possible, but spatially negligible. The pool took up a fraction of a percent of the available internal volume. In a ship this large, adding a few tons of water for a pool did not affect the trim calculations in any meaningful way. The sheer audacity of the construction suggests a civilization that was preparing for a very long, very lonely siege. The Aquila was built like a cathedral of war. It was robust, redundant, and massive. It was designed with the grim knowledge that it might be the only thing left functioning after a first strike. Western observers often focused on the offensive power, the 20 silos, the multiple warheads per missile, the megatonnage that could flatten the eastern seaboard of the United States. But to look at the Aquila is to look at a defensive strategy made manifest in steel. It was a turtle shell. It was a fortress. The thickness of the outer hull, the spacing of the internal compartments, the distance between the crew and the cold ocean outside, everything spoke of a desire to survive. As the 1980s dawned, this Leviathan slid into the waters of the White Sea, changing the calculus of the Cold War. It was a mysterious, terrifying shape that appeared on grainy satellite photos and in the nightmares of naval planners. But to the families of the officers who served aboard, it was simply the boat. A boat where their husbands and fathers would disappear for months, living in an artificial world of oak paneling and blue tiles suspended in the darkness. This was the illusion of luxury. It looked like a hotel, but it was a machine designed for the end of time. And to understand why the Soviet Union felt compelled to build such a monster, why they poured a significant percentage of their national GDP into these giants, we have to look beyond the ship itself. We have to look at the map. We have to understand the strategic trap that the Soviet Navy found itself in, a trap that left them with only one option: to build a submarine so large, so tough, and so well protected that nothing on Earth could stop it. The story of the Aquila is not just a story about a big submarine. It is the story of a nation that was cornered by geography and forced to innovate its way out. The swimming pool was not the point. The missiles were not even the point. The point was the ice. And to understand the ice, we must understand the impossible geography of the Soviet Union. The map of the world looks different depending on where you stand. From Washington, D.C., the oceans appear as open highways. The United States is a maritime nation by birthright, blessed with unhindered access to the Atlantic in the east and the Pacific in the west. Its fleets can sail from Norfolk or San Diego and disappear into the deep ocean within hours. For American naval planners, the sea is a cloak of invisibility. An Ohio-class ballistic missile submarine can slip out of port, dive into the deep Atlantic trench, and vanish into millions of square miles of open water. It is the ultimate stealth advantage, to be everywhere and nowhere at once. But from Moscow, the map tells a story of suffocation. The Soviet Union, for all its immense landmass, was geographically cursed when it came to the sea. It was a continental power trying to act like a maritime superpower, and geography fought it every step of the way. To the south, the Black Sea Fleet was locked behind the Turkish Straits, controlled by a NATO member. To the west, the Baltic Fleet was bottled up by Denmark and Germany. In the Far East, the fleet at Vladivostok had to pass through narrow straits monitored by Japan and South Korea to reach the open Pacific. And in the north, there was the Arctic. This was the strategic trap that defined the Cold War at sea. The Soviet Navy's Northern Fleet, based on the Kola Peninsula, was their most powerful striking arm. But to get their submarines into the Atlantic to threaten the United States, they had to pass through the GIUK Gap, the stretch of ocean between Greenland, Iceland, and the United Kingdom. This gap was the most heavily surveilled stretch of water on the planet. The United States and its NATO allies had wired the ocean floor with SOSUS, the sound surveillance system. These arrays of hydrophones listened for the distinctive acoustic signatures of Soviet submarines. If a Soviet boat tried to cross into the Atlantic, NATO knew. They would be trailed by attack submarines, tracked by maritime patrol aircraft, and hunted relentlessly. For a ballistic missile submarine, an SSBN, being tracked is a mission failure. The sole purpose of an SSBN is to remain hidden so that, in the event of a nuclear war, it can launch a retaliatory strike. If the enemy knows where you are, they can destroy you before you launch. This meant the Soviet Union could not copy the American strategy. They could not send their missile submarines roaming into the open Atlantic because they would likely die before they ever reached their patrol zones. The Americans had the luxury of the open ocean. The Soviets had a cage. So, in the 1970s, Soviet naval strategists made a radical decision. They stopped trying to break out of the cage. Instead, they decided to fortify it. They rewrote the rules of nuclear deterrence with a concept known as the Bastion Doctrine. The logic was simple and brutal. If the open ocean is dangerous, do not go there. Instead of sending missile submarines to the enemy's coast, keep them close to home. Keep them in the Barents Sea, the White Sea, and the Arctic Ocean, waters the Soviet Navy could control. This shifted the entire purpose of the Soviet surface fleet and air force. Their job was no longer just to project power outward. It was to create a steel umbrella over their own home waters. Destroyers, cruisers, and aircraft would patrol the surface, hunting for NATO intruders, while the ballistic missile submarines patrolled safely underneath. The submarine would not be a lone wolf hunting in enemy territory. It would be the king in the castle, protected by layers of guards. But the Bastion Doctrine had one major flaw. The waters close to the Soviet Union were often covered in ice. The Arctic ice cap is not a flat skating rink. It is a chaotic, shifting landscape of frozen violence. Ice ridges can extend dozens of feet downward into the water. Ice floes grind against each other, creating deafening noise that blinds sonar. It is a hostile, terrifying environment for a ship. But for the Soviet strategists, the ice was not an enemy, it was a shield. Ice provides the ultimate cover from aircraft. A P-3 Orion patrol plane cannot drop a torpedo through 10 feet of solid ice. It shields the submarine from surface ships, which cannot operate in the frozen pack. If a submarine could learn to live under the ice, to hide in the noise and the shadows of the polar cap, it would be invincible. It could sit there, just miles from the Soviet coast, and wait. This strategic pivot is the key to understanding the Akula. The Akula was not designed to be an ocean-roaming predator like the American Ohio class. It was designed to be a mobile underground missile silo. It was built to park under the ice and stay there. This mission profile explains every strange design choice that would later baffle Western observers. Why was the ship so wide? Stability in the turbulent waters under the ice. Why were the diving planes on the bow retractable? So they wouldn't snap off when surfacing through the ice. Why were the propellers shrouded? To protect them from ice blocks. Most importantly, the Bastion Doctrine dictated the ship's survivability requirements. If the Aquila was going to operate in the Bastion, it didn't need to be faster than an American hunter-killer sub. It didn't even need to be quieter necessarily. It just needed to be harder to kill. It needed to be tough enough to smash its way through the ice to launch its missiles. This requirement, to surface through the ice, was non-negotiable. An American submarine launches its missiles from the open sea. It floats to a launch depth, stabilizes, and fires. But a Soviet submarine under the polar cap has a roof over its head. To launch, it must break that roof. Imagine the physics of this maneuver. The submarine must rise from the depths and ram its sail and deck into a solid sheet of frozen water. It must deliver thousands of tons of force to shatter the ice, clearing a path for the missiles. If the submarine is too fragile, the ice will crush the conning tower. If the submarine is too light, it will bounce off. The Aquila had to be a battering ram. This necessity drove the structural reinforcements that added thousands of tons to its displacement. The sail, the tower that rises from the deck, was reinforced with high-strength steel and titanium. It was rounded and smoothed to distribute the shock of impact. The entire upper casing of the ship was armored against the ice. This was the trap of geography. The Soviet Union had to build a ship capable of fighting the environment before it ever fought the enemy. The Americans fought the Soviets fought the ice. The Bastion Doctrine also dictated the nature of the weapons. If the submarines were going to stay close to home, patrolling in the Barents Sea or even staying at the pier, their missiles needed immense range. To hit Washington, D.C. from the Barents Sea, a missile needs to fly over 5,000 miles. This required larger rockets, more fuel, and heavier payloads. This brings us to the critical intersection of strategy and engineering. The Soviet leadership demanded a submarine that could hide in the Bastion, survive the ice, and strike the United States from its own backyard. They handed this problem to the engineers at the Rubin Design Bureau and said, "Build it." The engineers looked at the requirements. They looked at the geography. And they looked at the missile they were given to work with. It is a common misconception that engineers design a vehicle and then fit the engine and weapons inside. In the world of strategic weapons, it is the opposite. The weapon exists first. The vehicle is just the delivery box. The box must be built to fit the contents. For the American Navy, the Trident missile was a marvel of compact efficiency. It was powerful, accurate, and small enough to fit into a sleek, efficient hull. The Ohio-class submarine was built around the Trident, resulting in a clean, hydrodynamic shape. The Soviets, however, were facing a crisis in missile technology. They were trying to transition from liquid-fueled rockets, which were volatile, dangerous, and noisy, to solid-fueled rockets, which were stable and safe. But their chemical industry lagged behind the West. They couldn't make the solid fuel as energetic or as compact as the Americans could. To get the same range and payload as the American Trident, the Soviet missile had to be much, much bigger. The missile that would arm the Aquila was the R-39. It was a monster. It weighed nearly 90 tons. It was over 50 feet long. It was essentially a space launch vehicle disguised as a weapon. And the Soviet Navy wanted 20 of them on a single ship. This was the moment the trap snapped shut. The strategists demanded a ship that could hide under the ice. The chemical industry provided a missile that was the size of a grain silo. And the geography demanded that the ship be tough enough to act as an icebreaker. Sergei Kovalev, the chief designer, stared at these contradictions. A conventional submarine hull is a cylinder, a long tube. To fit 2 rows of these massive R-39 missiles inside a single cylinder, The diameter of the tube would have to be enormous. It would be so wide that the pressure of the ocean would crush it. A single hull of that size was structurally impossible with the materials of the time. The conventional rules of naval architecture said it couldn't be done. You could not put 20 90-ton missiles into a submarine capable of diving deep and smashing ice. The math didn't work. But the Cold War did not accept impossible as an answer. The Bastion Doctrine was the only way the Soviet Union could guarantee its survival. The R-39 was the only missile that could reach the target. The ice was the only shield they had. So Kovalev did what great engineers do when faced with an unsolvable problem. He changed the question. If a single hull can't hold the missiles, he asked, why use a single hull? Why not build something that has never been built before? He stopped thinking about a submarine as a tube. He began to think of it as a catamaran. This decision, born from the desperate constraints of geography and industrial limitations, would lead to the creation of the most complex, redundant, and bizarre internal structure in the history of shipbuilding. It was the moment the Akula ceased to be a normal submarine and became a monster. The strategic trap had created the necessity. Now, the engineers had to provide the reality. The result would be a design so radical that when Western intelligence finally understood what they were looking at, they initially refused to believe it. It was a design that prioritized survival above all else. A design that accepted the brutality of the Arctic as a baseline condition. The Bastion Doctrine was not just a strategy on paper. It was the genetic code that shaped the steel, the titanium, and the very soul of the ship. It ensured that the Akula would never be a sleek racer. It would be a fortress, a castle in the ice. And inside that castle, the logic of the Cold War would reach its absolute, terrifying zenith. In the history of engineering, form usually follows function. But in the case of the Akula, form followed failure. Specifically, the failure of the Soviet chemical industry to match American efficiency. To understand the bizarre, hulking shape of the Typhoon-class submarine, you must first understand the object that broke the rules of naval architecture. The R-39 rifled ballistic missile. By the late 1970s, the arms race had moved to a new phase. Liquid-fueled missiles, which had powered the Soviet fleet for decades, were becoming a liability. Liquid fuel is toxic, volatile, and requires complex plumbing that makes noise, a death sentence for a submarine trying to hide. The Americans had already mastered solid fuel technology with their Poseidon and Trident missiles. Solid fuel is stable. It is quiet. It sits on the shelf like a giant candle, ready to burn at a moment's notice. The Kremlin demanded a solid fuel missile that could match the American Trident in range and payload. They wanted a weapon that could carry 10 nuclear warheads over 5,000 miles. The result was the R-39, NATO reporting name SSN-20 Sturgeon. The problem was energy density. Soviet solid propellants were simply not as powerful as their American counterparts. To achieve the same thrust, they needed more fuel. To hold more fuel, they needed a bigger casing. The result was a weapon of grotesque proportions. The R-39 weighed nearly 90 tons, 3 times the weight of the American Trident I. It was 53 feet long and nearly 8 feet in diameter. It was less a missile and more a small intercontinental spaceship. When the specifications for the R-39 landed on the desk of Sergei Kovalev at the Rubin Design Bureau, the crisis was immediate. A standard submarine layout places the missile silos in 2 neat rows behind the sail, piercing through the pressure hull. But the R-39 was so tall that it wouldn't fit inside a standard hull. It was so heavy that 20 of them would destabilize a conventional submarine. And most critically, it was so wide that a single pressure hull wrapping around 2 rows of these missiles would have to be nearly enormous in diameter. The physics of pressure hulls are unforgiving. As a cylinder gets wider, the water pressure exerts exponentially more force on its surface. To resist the crushing weight of the ocean depths, a hull of that diameter would require steel so thick it couldn't be welded, or titanium so expensive it would bankrupt the state. Kovalev faced an impossible choice. He could tell the Politburo that their missile was too big and the project was dead, a career-ending, if not life-ending, admission. Or he could throw away every rule of submarine design and invent something new. He chose the latter. He looked at the massive R-39 missiles and realized they could not go inside the pressure hull. They had to go outside. This was the birth of the underwater catamaran. Instead of one giant tube, Kovalev designed a ship made of two separate, parallel pressure holes. Imagine two submarines, each about the size of a Delta-class boat, laid side by side like twin brothers. Each of these holes was manageable in diameter, roughly 24 feet, allowing them to be built from standard high-strength steel capable of diving deep. Between these two parallel hulls, in the flooded space separating them, Kovalev placed the missile silos. The 20 massive R-39s would sit in the gap between the habitable sections, protected by the outer casing, but technically outside the pressure envelope of the crew compartments. This decision solved the size problem, but it created a monster of complexity. A submarine is not just a hull. It is a nervous system of pipes, wires, and corridors. If you have two separate hulls, how does the crew move between them? How does the captain command the ship? Kovalev's solution was to add more hulls. He didn't just stop at two. He added a third pressure hull above the main two, located directly under the massive sail. This would house the command center, the radio room, and the periscopes. Then he added a fourth hull at the very front to house the torpedo tubes and the loading mechanism. And finally, a fifth hull at the stern to connect the steering gear. The Akula was not one submarine. It was 5 separate pressure vessels linked together by connecting tunnels, all wrapped inside a thin, hydrodynamic outer shell made of steel. The space between the inner pressure hulls and the outer skin was flooded with water when the ship dived. This architecture is unique in the history of shipbuilding. No other nation has ever attempted it on this scale, and likely no one ever will again. It turned the submarine into a honeycomb of habitable spaces. It meant that a sailor going from the torpedo room to the engine room might have to walk up a ladder, through a tunnel into the command module, down another ladder, and into the other main hull. This complexity was the price of the missile. But as the design evolved, Kovalev and his team realized that this flaw offered a terrifying advantage. The multi-hull design inadvertently created the most survivable warship ever built. In a conventional submarine, a single hull breach is usually fatal. If a torpedo punches a hole in the pressure hull, water rushes in, the boat gets heavy, and it sinks to the bottom. But the Akula was built like a ship, with watertight bulkheads on a massive scale. The two main hulls were independent. They had their own reactors, their own turbines, their own steering controls. Theoretically, an Akula could take a torpedo hit that completely flooded one of the main hulls, killing half the crew and destroying one reactor, and the other hull could still function. The surviving half of the ship could still maneuver. It could still surface. And most importantly, it could still launch its missiles. This redundancy became central to the Soviet philosophy of the third strike. The first strike is the initial attack. The second strike is the immediate retaliation. The third strike is the vengeance of the survivors, the ability to keep fighting even after the world has already ended. The Akula was a zombie ship, designed to fight even when half dead. The layout also solved the bastion problem of ice protection. Because the missiles were located between the two main hulls, they were shielded from the sides. The outer casing of the ship was not just a skin, it was a bumper. The light hull, the outer shell, was coated in specialized rubber tiles to absorb sonar, but beneath that was steel stiffened to take a beating. The immense reserve buoyancy, the amount of water the ship pushes aside compared to its weight, was staggering. A normal submarine has about 10 to 15 reserve buoyancy. The Aquila had nearly 35. This meant that when it surfaced, it rode high in the water, looking more like a surface ship than a submarine. This extra buoyancy was the muscle needed to break the ice. It allowed the ship to generate upward force without needing speed. It could just float up and crush the ice ceiling with its back. But the most striking aspect of the internal architecture was how it shaped the daily life of the crew. Because the ship was so wide, essentially 2 ships wide, there was space that simply didn't exist on other submarines. The infamous swimming pool, the sauna, the gym, these were not placed there because the designers were feeling generous. They were placed there because the geometry of the connecting tunnels created voids that needed to be filled. The relaxation zone was located in the central module, suspended between the 2 main hulls. This was the safest place in the ship, protected by layers of steel and water on all sides. It was the heart of the vessel, both structurally and psychologically. Western analysts, looking at the blueprints years later, were stunned by the inefficiency of the design. The Aquila was huge, yet it carried the same number of missiles, 20, as the much smaller American Ohio class, which carried 24. It required a crew of 160 men. It needed 2 nuclear reactors instead of 1. It was expensive to build and expensive to maintain. From a purely economic standpoint, it was a disaster. It was a sledgehammer used to crack a nut. But from the standpoint of the Soviet military-industrial complex, it was a triumph. They had taken a massive, unwieldy missile and built a fortress around it. They had turned a disadvantage, lagging chemical technology, into an asset, extreme survivability. The Aquila was a monument to the Soviet ability to solve problems through brute force and scale. If you can't make it small, make it big. If you can't make it elegant, make it unbreakable. As the first hull, TK-208, took shape in the covered slipway of Severodvinsk Shipyard 402, the workers knew they were building something different. The titanium pressure hulls shone like silver before being covered by the outer steel skin. The sheer amount of metal involved affected the magnetic compasses of nearby ships. It was a beast born of compromise, but the result was a machine that felt less like a vehicle and more like a geography. It had its own internal weather. It had districts: the port hull, the starboard hull, the command module. A sailor could serve on an Aquila for years and never set foot in certain compartments. This compartmentalization was the physical manifestation of the paranoia that birthed it. Every system had a backup. Every backup had a manual override. The ship was designed with the assumption that everything would go wrong. The electronics might fail, the reactor might scram, the hull might be breached, the captain might be dead. But the ship had to survive, because if the Aquila died, the bastion fell. And if the bastion fell, the Soviet Union was defenseless. The impossible design was not just about engineering. It was about the psychology of a nation that expected the worst. They built a ship that could survive the end of the world. But to do that, they first had to make sure it could survive the environment that was trying to kill it every single day. The freezing, crushing, deafening reality of the Arctic Ocean. The Aquila was built to house the missile, but its daily battle was not with NATO. It was with the water itself. And in the frozen north, the water fights back. The Arctic is the only ocean on Earth with a ceiling. For a submarine operating in the Pacific or Atlantic, the surface is a sanctuary, a place to raise an antenna, vent atmosphere, or escape a sinking vessel. But in the Arctic, the surface is a tomb lid. It is sealed by ice that can be 10 feet thick, moving and groaning under the pressure of wind and current. To operate here is to be trapped between the crushing pressure of the deep and the impenetrable armor of the ice cap. The Aquila was built to break that ceiling. The capability to surface through polar ice is not merely a matter of engine power. It is a problem of delicate, violent physics. Most submarines are fragile. Their sails, the towers housing periscopes and masts, are filled with sensitive electronics and hydraulics. Ramming a standard submarine into a slab of ice is like ramming a television set into a brick wall. The Akula, however, approached the ice with a different philosophy: Archimedean violence. The secret lay in its reserve buoyancy. As noted, a typical submarine carries about 10 to 15 reserve buoyancy. This means when it surfaces, only a sliver of the boat sits above the waterline. The Akula had a reserve of nearly 35. This enormous margin meant the ship was constantly fighting to stay underwater. It wanted to float. When the captain ordered a surfacing maneuver through the ice, the crew would carefully position the ship, hovering just beneath the frozen sheet. Then, they would blow the main ballast tanks with high-pressure air. The result was 48,000 tons of displacement suddenly becoming lighter than the water it displaced. The ship would rise with terrifying force. It didn't cut the ice, it punched it. The rounded, reinforced sail and the armored back of the missile deck would strike the ice from below, shattering it into massive blocks that cascaded off the hull. The ship would shudder, the steel groaning, but it would break through. This maneuver, surfacing through 2.5 meters over 8 feet of solid ice, allowed the Akula to turn the entire Arctic Ocean into a launch pad. It could hide under the ice for weeks, invisible to satellites, and then smash its way into the open air to fire its missiles within minutes. No other submarine could do this with such reliability or violence. It was a capability that terrified NATO planners. How do you find a needle in a haystack when the needle can hide inside the hay? But hiding is not just about physical cover. In the silent war of the deep, survival depends on sound. This brings us to the most controversial aspect of the Akula's design: its stealth. For decades, the gold standard of submarine warfare was silence. The American doctrine, honed by the Rickover era, was absolute acoustic invisibility. The U.S. Navy built ships like the Ohio class and the later Seawolf class with tolerances measured in thousandths of an inch, machinery mounted on complex rafts to isolate vibration, and propellers designed by supercomputers to eliminate cavitation. The goal was to be a hole in the water, undetectable. The Akula was different. It was not loud, but it was not a ghost. Western analysts initially mocked the Soviet designs, pointing out that their machinery was less refined, their pumps noisier. But this criticism missed the strategic point. The Akula was never meant to be the quietest submarine in the ocean. It was meant to be the quietest survivable submarine in the Bastion. The sheer size of the Akula gave it a unique acoustic advantage. The double hull construction acted as a massive sound baffle. The noise-making machinery, the turbines and reduction gears, was suspended inside the inner pressure hulls. Between that machinery and the ocean was the pressure hull wall, then a layer of water, then the outer light hull, which was coated in thick anechoic tiles, rubber mats designed to absorb sonar pings. This Matryoshka doll layering meant that while the internal machinery might be louder than an American boat, much of that noise was trapped inside the ship's own complex structure. Furthermore, operating in the Arctic gave the Akula a home field advantage. The marginal ice zone is a cacophony of natural noise. Ice cracking, shifting, and grinding creates a background roar that can deafen passive sonar. In this environment, quiet enough is just as good as silent. The Soviet doctrine was pragmatic. If they can't hear us over the ice, we are invisible. If they do hear us, We are too tough to kill. While the Americans played a game of hide and seek, the Aquila played a game of armored fortress. If an American attack submarine, like a Los Angeles class, detected an Aquila, it still had a problem. The Aquila's double hull was spaced so widely that a standard torpedo might detonate against the outer hull and fail to penetrate the inner pressure hull. The explosion would wreck the outer skin and sensors, but the crew and the reactor would be safe inside the inner sanctum, separated by feet of water and steel. To kill an Aquila, you didn't just need to hit it, you needed to hit it perfectly, or hit it twice. But the Aquila was not just a passive victim waiting to be hunted. It was a sensor platform of immense power. The blunt, massive bow of the ship housed the SCAT-KS sonar suite, shark gill. Because the bow was so wide, the sonar array could be enormous. In the world of sonar, size matters. A larger array can detect lower frequencies at longer ranges. The Aquila could listen to the ocean with a level of sensitivity that rivaled surface ships. It could track multiple contacts simultaneously: icebergs, surface ships, and enemy submarines. This situational awareness was critical. The Aquila wasn't blind brute force. It was a watchful giant. Its sensors were designed to exploit the specific acoustic properties of the polar waters, utilizing convergence zones, where sound waves bend and focus, allowing detection over dozens of miles. The ship also carried a unique defense against the very ice it called home. In the shallow, treacherous waters of the Arctic shelf, looking up is just as important as looking down. The Aquila was equipped with specialized mine detection and ice profiling sonar. These high-frequency systems scanned the ceiling, looking for polynyas, patches of thin ice, or open water where the ship could surface without smashing its way through. This capability turned the Aquila into a grazer. It would drift slowly under the ice pack, scanning upward, looking for a weak spot in the roof. When it found one, it would rise, breach, and listen for the radio signals from Moscow that would tell it whether the world was still there. There is a specific, chilling rationality to this design. The Aquila was an environmental specialist. An American Ohio-class submarine is a deep-water creature, uncomfortable in the shallow, jagged chaos of the Arctic shelf. The Aquila was an ice creature. It was built to endure the cold, the pressure, and the noise. However, the environment inside the ship was just as critical as the environment outside. While the hull battled the ice, the systems inside battled the heat. 2 OK-650 nuclear reactors, generating 380 megawatts of thermal energy, powered the behemoth. These reactors were workhorses, designed to provide the immense torque needed to push the ship's bulk. The cooling systems for these reactors were a marvel of plumbing. They drew in freezing seawater, circulated it through heat exchangers, and pumped it back out. But in the event of a crisis, the Aquila had a feature that few Western submarines possessed: the ability to run its coolant pumps on natural circulation at low power. This meant that, at low speeds, the noisy coolant pumps could be turned off entirely. The hot water would rise and the cold water would fall naturally, keeping the reactor safe while eliminating one of the primary sources of noise. This tactical silence mode allowed the giant to drift like a ghost. The interplay between stealth and survivability created a unique tactical doctrine. The Aquila didn't run from a fight, it absorbed it. In war games, Soviet commanders theorized that if an Aquila was detected, it should simply retreat deeper into the ice, into the bastions where NATO ships feared to tread. It would become a fortress in a frozen wasteland, guarded by surface ships above and mines below. This was the ultimate expression of the Soviet naval philosophy: deny the enemy victory, not by being perfect, but by being endure. The Americans built Ferraris, high performance, fragile, expensive. The Soviets built a tank, but a tank requires a crew, And a tank that stays underwater for 120 days requires a crew that doesn't go insane. The technological marvels of the hull, the sonar, and the reactors were useless if the men operating them broke down. The next layer of the Akula's design, the one that captured the world's imagination, was not about physics or acoustics. It was about psychology. Why did the Soviet Union, a nation known for its austere living conditions and utilitarian military, build a submarine with a bird aviary? Why did they put wood paneling in a warship? The answer lies in the specific terror of the long patrol. The Akula was not just a machine, it was a closed ecosystem. And in a closed ecosystem, the most fragile component is the human mind. The human mind is not built for the deep ocean. It is evolved for the savanna, for the rhythm of day and night, for the sensory input of wind, changing light, and the smell of rain. When you seal a human being inside a steel tube, submerge them hundreds of feet underwater, and keep them there for 3 or 4 months, you are conducting a dangerous biological experiment. The crews of ballistic missile submarines face a specific kind of psychological torture, boredom laced with existential dread. Unlike attack submarine crews, who hunt and track targets, the boomers have only one job: to wait. To wait for a radio signal that orders them to end the world. Day after day, week after week, they drill for the apocalypse. They practice turning the keys. They practice the launch sequence. And then they go back to their bunks, drink tea, and wait some more. In the cramped confines of earlier Soviet submarines, this pressure was compounded by physical misery. Bad air, high humidity, cramped bunks, and the constant smell of diesel and unwashed bodies led to higher rates of fatigue, illness, and error. In a system where a single mistake could cause a reactor meltdown or an accidental missile launch, a tired sailor was a deadly liability. This is why the Akula was different. The luxury that Western media mocked was, in reality, a calculated medical countermeasure. The Soviet Navy's medical researchers understood that to keep a crew sharp for 120 days or more, they needed to trick the brain. They needed to provide sensory inputs that mimicked life on land. This philosophy birthed the recreational zone in the Akula, a space that became legendary even before the first ship was launched. The swimming pool was small, barely 2 meters wide and 4 meters long, filled with fresh or desalinated water. But the sensation of weightlessness in water, the feeling of liquid on skin that wasn't freezing ocean spray, was a powerful stress reliever. Next to it was the sauna, lined with real oak. The smell of heated wood is a terrestrial smell. It triggers memories of the dacha, of the forest, of home. It grounded the sailors, reminding them that a world existed outside the titanium pressure hull. There was a solarium with UV lamps. In the darkness of the polar winter, where the sun might not rise for months even if they surfaced, vitamin D deficiency and seasonal affective disorder were real operational threats. The artificial sun kept their circadian rhythms somewhat synchronized. There was the gym, essential for preventing muscle atrophy in a confined space. There was a living corner with caged birds and aquariums. The sound of a bird chirping is an acoustic anomaly on a submarine. It cuts through the constant, low-frequency hum of the ventilation and the reactor pumps. It is a sharp, organic sound that signals life. The crew mess hall was designed to look less like a military cafeteria and more like a dining car on a train. There were paintings on the walls, landscapes of birch forests and Russian meadows. The officers had cabins that allowed for a semblance of privacy, a rare commodity in the submarine service. The sailors called it the Floating Hilton. But this nickname carried a heavy irony. The Hilton was wrapped inside a weapon of mass destruction. This brings us to the central paradox of the Akula, the coexistence of civilization and apocalypse. Imagine a sailor sitting in the sauna, sweating out the toxins of the shift, joking with his comrades. He is relaxed. He feels human. 10 minutes later, That same sailor walks through a bulkhead, climbs a ladder, and sits in front of a console that controls the targeting solution for 10 nuclear warheads, each capable of leveling a city the size of New York. The bread served in the mess hall was baked fresh daily in onboard ovens. The smell of baking bread wafted through corridors that ran parallel to missile tubes loaded with solid rocket fuel. The juxtaposition is jarring. It forces us to confront the reality of deterrence. Deterrence relies on the idea that the people holding the weapons are rational, stable, and capable. If the crew of a nuclear submarine were living in squalor, exhausted, and on the verge of a breakdown, the deterrent would be unstable. A madman might launch without orders. A tired crew might crash the ship. By building a humane ship, the Soviet Union was trying to ensure the reliability of its inhuman weapon. The crew of the Akula was elite. They were the best the Soviet Navy had to offer. Officers were highly trained engineers, often with advanced degrees. Conscripts were screened rigorously. To serve on an Akula was a badge of honor. It meant you were trusted with the state's most valuable asset. Interviews with former crew members reveal a deep affection for the ship. They didn't fear it, they loved it. They trusted its size. In the rough waters of the Barents Sea, where smaller submarines would roll and pitch violently, inducing seasickness and fatigue, the Akula was a rock. Its massive displacement absorbed the energy of the waves. It was a stable platform, a quiet home in a storm. One former commander recalled that the sheer volume of the ship gave a sense of psychological freedom. You could walk, he said. You could actually take a walk. On a standard submarine, a walk is 3 steps and a turn. On the Akula, you could walk the length of the missile deck tunnel. This physical movement allowed for the dissipation of nervous energy. However, the Hilton paradox also highlights the economic madness of the late Soviet era. While the sailors on the Akula ate fresh bread and swam in a heated pool, the citizens of the Soviet Union were standing in lines for basic groceries. The economy was stagnating. The cost of maintaining these underwater cities was astronomical. Every tile in that pool, every oak plank in that sauna, was paid for by a state that was slowly going bankrupt. The Akula was a microcosm of the Soviet tragedy, a technological masterpiece built by a dying system. It was a projection of power that the foundation could no longer support. The psychological stability of the crew was purchased at the expense of the nation's economic stability. The Akula was, in many ways, the ultimate expression of the Soviet priority of defense over butter. The state would starve, but the missiles would be warm. Yet, for the men inside, the politics didn't matter. What mattered was the routine, the shift changes, the movies shown in the mess hall, the ritual of the sauna. These small fragments of normal life kept the horror of their mission at bay. They allowed the crew to compartmentalize. They were not monsters, they were technicians. They were fathers and husbands, performing a job that required them to be ready to kill millions. The pool and the birds helped them forget that fact, just enough to function. This compartmentalization is the most chilling aspect of the Cold War. It wasn't fought by bloodthirsty zealots. It was maintained by calm, professional men who ate good food, exercised, and then sat quietly next to the button. The Akula made the end of the world comfortable. It domesticated the apocalypse. As the 1980s drew to a close, the crews of the 6 Akula submarines continued their silent patrols under the ice. They were the peak of Soviet naval power. They were the safest, most comfortable, most powerful sailors in history. But history has a way of changing course when you least expect it. The threat to the Akula would not come from American torpedoes or the crushing pressure of the deep. It would not come from a nuclear war. The threat came from the land they were protecting. The system that built the floating Hilton was beginning to crack. The ruble was collapsing. The Berlin Wall was trembling, and the giant sharks, patrolling in their silent loops, were about to find themselves swimming in a world that no longer could afford to feed them. The tragedy of the Akula is that it was built for a war that never happened, only to be destroyed by a peace it wasn't designed to survive. The luxury would soon turn into a burden, the missiles would turn into liabilities, and the crews who loved their ships would be forced to watch them die, not in battle, but in the rust and neglect of a new era. By 1991, the Soviet Union had ceased to exist. The red flag over the Kremlin was lowered, replaced by the tricolor of the Russian Federation. For the world, it was a moment of relief. The Cold War was over. The threat of nuclear annihilation seemed to evaporate overnight. But for the Typhoon-class submarines, this new era was not a liberation. It was a death sentence. The collapse of the Soviet state severed the complex arteries of supply and maintenance that kept these leviathans alive. A submarine of this complexity requires a nation-state to support it. It needs specialized parts from factories in Ukraine, electronics from the Baltics, and funding from Moscow. Suddenly, those factories were in foreign countries. The funding dried up, the supply chains shattered. The Northern Fleet, once the pride of the superpower, fell into disarray. Officers went unpaid for months. The pierside infrastructure in Zapadnyaya Litsa began to crumble. The power lines that fed the docked submarines failed, forcing the crews to run the reactors just to keep the ships warm and the lights on. The 6 Akulas, Dmitry Donskoy, Simbirsk, Arkhangelsk, Severstal, TK-202, and TK-12, sat at their moorings, heavy and silent. These were the most expensive naval assets Russia possessed, yet the new government could barely afford to feed the sailors guarding them. The floating Hiltons became cold, dark iron tombs. The swimming pools were drained. The saunas sat unused. The birds in the aviaries died or were taken home by crew members. But the real crisis was hidden deep inside the missile silos. The R-39 missiles that gave the Akula its purpose were solid-fueled. Unlike liquid fuel, which can be drained and replaced, a solid-fuel rocket is a chemical block. It is a single, massive grain of propellant. Over time, the chemical composition of this block begins to degrade. The binder that holds the fuel together can crack. Microfractures form. If a solid rocket motor with a cracked grain is ignited, the flame front rushes into the cracks. The surface area of the burn increases instantaneously. The pressure inside the casing spikes. The missile doesn't fly, it explodes. Every solid fuel missile has a use-by date. By the mid-1990s, the R-39 missiles on the Akulas were approaching theirs. In a functioning Soviet Union, the industrial complex would have simply built new batches of missiles. They would have swapped the old ones out during routine maintenance. But the factory that built the R-39 guidance systems was now in independent Ukraine. The chemical plants that mixed the propellant were in disrepair. The production lines were dead. Russia found itself in a terrifying strategic bind. It possessed the world's largest submarines, capable of surviving the apocalypse, but they were carrying weapons that were turning into ticking time bombs. Without new missiles, the Akulas were just 48,000-ton cargo ships carrying expired explosives. The Russian Navy faced a choice. They could try to restart production of the R-39, which was politically and economically impossible. Or they could design a new missile to fit the Akula. They chose the latter. The project was called BARC. The BARC missile, SSNX-28, was intended to be the savior of the Typhoon class. It was designed to be a modern, more efficient solid-fuel missile that would extend the service life of the submarines by decades. The plan was to refit the existing ships to carry this new weapon, but the BARC was cursed from the start. The design bureau in charge, the Makeyev Rocket Design Bureau, was struggling with the same brain drain and funding shortages as the rest of the country. When they finally built the prototypes, the results were disastrous. The first test launch failed. The missile exploded shortly after leaving the water. The second test failed. The third test failed. The BARC was heavier than the R-39, forcing even more modifications to the already massive submarines. It was expensive, unreliable, and dangerous. In 1998, after a catastrophic failure where the missile self-destructed, the Russian government made a ruthless decision. They canceled the Bark program. This decision effectively killed the Akula class. Without the Bark, there was no weapon for these ships. The original R-39s were now dangerously expired. The Navy had to begin offloading them, gingerly lifting the 90-ton rockets out of the silos with cranes, treating them like unstable nitroglycerin. One by one, the giant sharks were disarmed. The tragedy of the situation was palpable. The ships themselves were still relatively young. The titanium hulls were pristine, immune to corrosion. The reactors had decades of fuel left. The machinery was sound. Structurally, they could have sailed for another 20 years. But a warship without a weapon is a liability. The strategic logic that had birthed them, the bastion, the ice, the massive redundancy, was now irrelevant. The new Russian Federation didn't need a fleet of 6 underwater cities to deter a West that was sending them food aid. They needed smaller, cheaper, more flexible submarines. The Akulas became strategic reserves. This is military euphemism for mothballed. They sat at the pier, their crews reduced to skeleton maintenance teams. The snow piled up on their massive decks. The paint began to peel. The West, meanwhile, watched this collapse with a mixture of relief and anxiety. A rusting nuclear submarine is not just a sad sight. It is an environmental hazard. The reactors were still hot. The spent fuel needed to be secured. The materials inside, highly enriched uranium, titanium, sensitive guidance technologies, were vulnerable to theft or accident in the chaos of the Wild East of the 1990s. The United States, through the Cooperative Threat Reduction Program, known as Nunlugar, began to fund the dismantling of the Soviet fleet. This created one of history's strangest ironies. American tax dollars were paying to destroy the very machines that had been built to destroy America. But the Russians were reluctant to let go of the Akula entirely. It was a symbol of national pride. It was the king of the sea. To scrap them all was an admission that Russia was no longer a superpower. So, a compromise was reached. 3 of the ships, TK-12, TK-202, and TK-13, would be scrapped. They were the oldest, and they were deemed too expensive to save. But 3 remained. Dmitry Donskoy, TK-208, Arkhangelsk, TK-17, and Severstal, TK-20. Arkhangelsk and Severstal were kept in reserve, loaded with the last few remaining functional R-39 missiles, holding on to a ghostly semblance of operational status. But as the 2000s progressed, even those missiles expired. The ships became empty shells. They were kept on the roster, their crews painting the hulls and running drills, but they were toothless. The story could have ended there. The Akula class could have faded into history as a monolithic failure of the late Cold War, a dinosaur that died because the climate changed. But there was one ship that refused to die. The lead ship of the class, Dmitry Donskoy, had been in dry dock for over a decade. It had been undergoing a refit for the ill-fated Bark missile system when the Soviet Union collapsed. It sat there, cut open, half-finished, for years. It was a rust bucket, a skeleton in the shipyard. However, when the Bark was canceled, Russia decided to develop a different missile, the Bulava. The Bulava was much smaller than the R-39. It was designed for the new, smaller Boré-class submarines. But the Boré-class wasn't built yet. The Navy needed a platform to test this new missile. They needed a submarine that was big enough to handle the experimental launches, tough enough to survive a test failure, and available. They looked at the gutted hull of the Dmitry Donskoy. It was the ultimate recycling project. They would take the biggest submarine ever built, designed for the biggest missile ever made, and modify it to test a small, modern missile. The resurrection of Dmitry Donskoy is a testament to the stubbornness of the Russian naval engineers. In the midst of economic ruin, they slowly, painfully rebuilt the ship. They replaced the bark silos with new launch tubes for the Bulava. They upgraded the electronics. They brought the reactor back online. In 2002, Dmitry Donskoy rolled out of the shipyard. It was no longer a combat vessel. It was a test laboratory, a teacher. The other sisters were not so lucky. They remained at the pier, cold and empty. But Donskoy sailed again. It went back to the White Sea. It went back under the ice. It became the bridge between the Soviet past and the Russian future. The collapse of the giant was not a singular event. It was a slow, agonizing process of attrition. It was a war of economics, chemistry, and politics. The Akula was undefeated in battle, but it was defeated by the calendar. The solid fuel cracked. The treaties were signed. The money ran out. The image of these massive ships sitting side by side in the freezing gloom of the Kola Peninsula is one of the most haunting of the post-Cold War era. They were like beached whales, too heavy to move, too magnificent to ignore. They were monuments to a time when the world seemed simple, binary, and terrifying. Now, they were just scrap metal waiting for the torch. All except for one. For nearly 2 decades, the Dmitry Donskoy, TK-208, sailed alone. While its sister ships were towed away to be gutted, the firstborn of the Akula class became a legend in its own right. It was no longer a carrier of the apocalypse, but a guardian of the future. As a test platform for the new Bulava missile system, the Donskoy was the only ship in the Russian Navy capable of enduring the violent failures of early missile testing. When a test missile explodes inside a silo or fails to ignite upon surfacing, the damage to a standard submarine can be catastrophic. But the Donskoy was built with that insane paranoid redundancy of the Cold War. It could shrug off an explosion that would sink a lesser vessel. In this new role, the ship found a noble second life. It was the teacher that allowed the next generation of Russian submarines, the Bore class, to be born. The Donskoy became a celebrity. It was the ship shown on Russian state television, crashing through the ice, firing missiles into the white sky. It was the vessel that hosted foreign dignitaries. It was the last functioning reminder of the era of giants. For the sailors who served on her in the 2000s and 2010s, life was a strange mix of modern testing protocols and Soviet nostalgia. The swimming pool was refilled. The sauna was heated. The bird cages, however, remained mostly empty, a small concession to the new reality. But even legends age. The Donskoy was kept alive far past its intended service life. By 2020, the Bore-class submarines were operational. The testing was done. The teacher was no longer needed. The decision to decommission the Dmitry Donskoy was finalized in 2022. The last giant was finally told to rest. While the Donskoy enjoyed its long twilight, its sisters met a much more violent end. The dismantling of an Akula is not a simple scrapping operation. It is a geological event. You cannot just cut up a nuclear-powered mountain with blowtorches. The process requires specialized industrial facilities that didn't even exist when the ships were built. The ships were towed to the Zvezdokka shipyard. There, the outer steel skin, the light hull, was stripped away, revealing the alien, skeletal form of the 5 internal pressure hulls. Seeing an Akula without its skin is disturbing. It looks less like a ship and more like a cluster of massive metallic organs. The titanium and high-strength steel resisted the cutting tools. It was a fight to the very end. The most dangerous part of the process was the removal of the reactor compartments. These sections, still radioactive, had to be cut out of the hull in one piece. They were sealed, painted with special anti-corrosion coatings, and floated onto heavy lift barges. They were taken to Sita Bay. Sita Bay is one of the most surreal places on Earth. It is a storage facility on the Kola Peninsula, a graveyard for the nuclear hearts of the Soviet Navy. There, on a massive concrete pad, sit row after row of reactor compartments. They look like giant steel cans, each the size of a house. Among them are the massive, double reactor blocks of the Akula class. They will sit there for decades, perhaps centuries, waiting for the radiation to decay to safe levels. It is a nuclear Stonehenge, a silent monument to the physics of the Cold War. The irony of this destruction is impossible to ignore. The funding that paid for the specialized cutting equipment, the transport barges, and the secure storage facility at Sita Bay did not come entirely from Moscow. A significant portion came from Washington. This brings us to the Noon-Lugar Cooperative Threat Reduction Program. In the 1990s, the United States realized that a broke Russia with surplus nuclear submarines was a global security nightmare. If the Russians couldn't afford to dismantle these ships safely, the reactors might leak, or the weapons materials might be sold on the black market. So the U.S. Congress appropriated billions of dollars to help their former enemy destroy its own weapons. American contractors worked alongside Russian engineers. American inspectors walked the decks of the very submarines that had been built to vaporize American cities. They watched as the guillotine shears cut the wings off bombers and the plasma torches sliced through submarine hulls. There is a famous photograph from this era. It shows a group of American senators and Russian admirals standing on the snow-covered deck of an Akula. They are smiling, shaking hands. Behind them, the missile silos are open and empty. It is a profound image. The Akula was designed to be unkillable in war. The armor, the double hulls, the redundancy. It was all meant to defeat depth charges and torpedoes. But it could not defeat a line item in a budget. It could not defeat a handshake. The only thing that could kill the Akula was cooperation. The dismantling of TK-20 Severstal and TK-17 Arkhangelsk was particularly poignant. These ships were younger than the Donskoy. They were in better condition. There were proposals to turn them into underwater liquefied natural gas, LNG tankers. There were plans to convert them into cargo ships for Arctic supply runs. The internal volume was certainly there, but the economics never worked. A nuclear reactor is a terrible way to power a cargo ship. Too expensive, too much security required. And so the proposals died. The ships sat in reserve for years, rusting quietly, until the order finally came to scrap them. As the torches cut into the titanium, they were erasing a civilization's peak achievement. The Soviet Union had poured its best science, its best materials, and its best men into these ships. They were the pyramids of the USSR. And like the pyramids, they were built with a singular focus on the afterlife. In this case, the afterlife of a nuclear exchange. The metal from the scrapped Akulas has been recycled. The high-grade steel and titanium have been melted down and repurposed. It is possible that the metal from the hull of a doomsday machine is now part of a bridge, a medical implant, or a civilian airliner. The swords have literally been beaten into plowshares, but the memory of the ships remains. For the people of Severodvinsk and the naval towns of the north, the Akula is still a source of fierce pride. It represents a time when they built the biggest, toughest thing in the world. The long goodbye of the Akula class lasted longer than the Cold War itself. The first ship was laid down in 1976. The last one will be fully scrapped in the late 2020s. That is a 50-year arc. In that time, the world changed completely. The Soviet Union fell. The internet was invented. The climate warmed, shrinking the very ice cap the Akula was designed to hide under. The strategic logic of mutually assured destruction evolved into a more complex, multipolar chaos. Yet, through it all, the Akulas were there. First as threats, then as burdens, then as partners in disarmament, and finally as scrap. The Dmitry Donskoy's final voyage to the scrapyard was a funeral for an era. As it was towed out of the harbor, stripped of its weapons and sensors, it looked small against the vastness of the ocean. The shark that used to hunt in the deep was now just a helpless hulk. But there is a dignity in its end. It did not sink in battle. It did not suffer a catastrophic accident like the Kursk. It did not launch its missiles in anger. It lived a full life, did its job of deterrence, and then submitted to the inevitable cycle of time. The reactor blocks sitting in Cedar Bay are the final footprint. They are the mute witnesses to the madness and the genius of the 20th century. They remind us that we built monsters. We built machines capable of breaking the world. And then, largely through luck and a few moments of sanity, we took them apart. The story of the dismantling is not a tragedy, it is a triumph. Every piece of steel cut from an Akula is a victory for human survival. Every empty silo is a testament to a war that never went hot. The giant is gone. The water in the pool has long since drained away. The oak panels of the sauna have rotted or been scavenged. But the lesson of the Akula remains. It teaches us that technology is only as dangerous as the political intent behind it. And it teaches us that even the most invincible machines are ultimately mortal. When future historians look back at the 20th century, digging through the digital archives and the rusted remnants of our time, they will find few objects as perplexing as the Project 941 submarine. It will stand out in the fossil record of human engineering like a strange, armored dinosaur, a creature that was too big, too complex, and too specialized for the world that birthed it. To dismiss the Akula as a mere weapon, or worse, as a folly of Soviet excess, is to miss its deeper significance. The Akula was a civilizational artifact. It was a physical manifestation of a specific worldview, frozen in titanium and steel. It represented a society that believed in the absolute power of the material world. The Soviet Union was an atheistic state, but it built its machines with a religious fervor. They believed that if you poured enough concrete, forged enough steel, and calculated enough physics, you could overcome any obstacle, even the geography of the planet, even the threat of extinction. The Akula was the ultimate expression of heavy industry socialism. It was not built for profit. No commercial shipyard would ever dream of constructing such a monstrosity. The return on investment was zero. It was built because the state demanded safety, and the state had the power to mobilize the resources of half a continent to achieve it. It was a pyramid built not for a pharaoh, but for the concept of deterrence. In a way, the Akula was the most honest object of the Cold War. It did not hide its purpose. It did not pretend to be a peacekeeper. It was a machine built to survive the end of the world, and to ensure that the enemy died too. It was brutal, direct, and terrifyingly logical. But it was also a deeply human object. The swimming pool, the sauna, the bird cages, these were not eccentricities. They were admissions of frailty. They were the engineers acknowledging that no matter how much steel you wrap around a man, he is still just a man. He still needs warmth. He still needs to see a bird fly. He still needs to feel water that isn't trying to kill him. This tenderness inside the belly of the beast is what makes the story of the Akula so haunting. It suggests that even in the darkest moments of the nuclear standoff, the value of human life, or at least the sanity of the human mind, was still part of the equation. We built machines to kill millions, but we also built them to keep 160 men happy. The Akula also serves as a mirror to our own fears. We look at it and we see the scale of our capacity for destruction. We see that we are capable of organizing our entire societies around the production of death. The thousands of people who built the Akula, the welders in Severodvinsk, the chemists in Ukraine, the miners in Siberia, were all working together to build a machine whose only true success would be to never be used. That is the final, strange victory of Project 941. It succeeded. It was built to deter a first strike. It did that. It was built to protect the Soviet Union from nuclear blackmail. It did that. It was built to navigate the impossible environment of the Arctic. It did that. And when its time was over, it was taken apart by the very enemies it was built to destroy. As we stand in the 21st century, the threat of nuclear war feels both more distant and, paradoxically, more chaotic. The binary simplicity of the Cold War is gone. The days of two superpowers staring each other down with thousands of warheads are over. We have traded the giant monsters for swarms of drones and cyber weapons. But the Akula reminds us of the stakes. It reminds us that we once stood on the edge of a cliff, looked down, and decided to build a house there. The silence of the Arctic is different now. The ice is thinning. The great black shapes of the typhoons no longer patrol the deep. But if you listen closely to the history, you can still hear them. You can hear the hum of the turbines, the creak of the ice against the hull, and the splash of water in a tiny swimming pool at the bottom of the world. They are gone, but they should not be forgotten. They are the giants that carried our nightmares on their backs so that we could sleep in peace. There is a profound quiet that settles over the mind when you contemplate a machine like the Akula. It forces you to ask a question that is uncomfortable but necessary. What does it say about a species that its greatest engineering achievements are often its most deadly weapons? We spent more treasure, more genius, and more labor on the means of our own destruction than on almost anything else in the 20th century. We reached for the stars with rockets born from missiles. We split the atom not to light our cities, but first to level them. And yet, looking at the empty reactor blocks in Sita Bay, looking at the razor blades made from recycled submarine hulls, there is a glimmer of hope. The Akula was a weapon of the apocalypse. It was loaded, aimed, and ready for decades. Hundreds of different men held the keys. Hundreds of times the order could have been given. Hundreds of times a mistake could have been made. But the order never came. The mistake never spiraled. The keys never turned. Humanity built a gun, pointed it at its own head, and held it there for 40 years. And then, slowly, carefully, we lowered it. We didn't pull the trigger. That is the legacy of the Akula. It is not just a story of engineering or war. It is a story of restraint. It is proof that we can build monsters, but we can also choose not to become them. We are a flawed, dangerous, fearful species. But when it mattered most, we chose life. We chose to let the pool water drain away, to let the birds go free, and to cut the giants into pieces. Thank you for spending part of your day with us on this journey into the deep. If this story meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.